Hello, my name is Amit Chauhan. I'm a principal engineer at Yugabyte. Today we are going to discuss about how to design an always-on Java application with YugabyteDB as a database. We will be delving into the art of building applications that remain steadfast even in the face of adversity. So buckle up because we have got an action-packed agenda ahead. First up, we'll dive into why resiliency is not just a buzzword, but a crucial factor in today's tech landscape. Next, we'll explore the core principles of resilient design, your blueprint for building robust applications. Then we'll unveil the inner workings of YugabyteDB's architecture, the secret sauce behind resilient databases. After that, we'll immerse ourselves in the world of design patterns for resiliency, the clever strategies that keep your apps running smoothly. Finally, get ready to see theory in action. We'll dissect the high-level design of simple Java app I've crafted using the very principles we discussed. And the grand finale, we'll use this very app to demonstrate real-world resilience and scaling. So stick around for a thrilling ride through the world of resiliency. So let's start by addressing a fundamental truth in the world of modern applications. The cost of downtime can be staggering. When your application experiences downtime, it's not just a matter of lost revenue, it's also about the erosion of user trust. Think about it. In today's highly competitive landscape, users expect your services to be available around the clock. That's 24 by 7, 365 days a year. Any deviation from this expectation can tarnish your company's reputation. Once trust is damaged, it's not easily regained. This is why resiliency is not merely a buzzword, it's a strategic imperative. It's about ensuring that your applications are always available even in the face of challenges. In the next few slides, we'll explore the principles and technologies that can help you build applications that stand up to the test of the time and user expectations. Now let's talk about distributed Java applications. Now that we have established why resiliency is paramount, let's delve into the world of distributed applications. Distributed applications are all about spreading your application components across multiple nodes. It's like building a robust web that can handle scalability and performance challenges with ease. Picture this. Your application isn't confined to a single server. Instead, it's distributed across multiple nodes or servers, each with its own set of responsibilities. Take a look at this simplified architecture diagram on the side. In this diagram, we have multiple nodes or servers, each handling different part of the application. The distribution of tasks allow us to scale horizontally, which means we can handle increased workloads by adding more nodes. However, with great power comes great complexity. The moment we start distributing our application, we introduce a whole new set of challenges. Things like network failures, latency, and data consistency become real concerns that we need to address. And that's what we'll be exploring in the upcoming slides. So now that we have explored why resiliency is vital and understood the complexity of distributed application, let's dive into the principles that underpin resilient design. Resilient applications are like well-constructed fortresses. They are built to withstand challenges and keep running smoothly, even in the turbulent times. Here are 4 fundamental principles that form the foundation of resilient design. Number 1, redundancy. So imagine having a spare key to your house. Redundancy in application design means duplicating critical components like servers or databases to ensure that availability even if one fails. It's like having a spare key when you need it most. Number 2, failover. Think of failover as your backup plan. When the component fails, a resilient system automatically switches to a backup system without missing a beat. It's like seamlessly switching to a backup generator when the power goes out. Number 3, Load balancing. Picture a well-organized traffic cop directing vehicles at a busy intersection. So load balancing is similar. It distributes incoming workloads evenly across multiple resources, preventing any single resource from being overwhelmed. It's like ensuring every lane of traffic moves smoothly. Number four, isolation. So in the world of in resilience, isolation is like having firewalls that prevent fires from spreading. It isolates components so that if one fails or becomes compromised, it doesn't bring down the entire system. It's like containing a small fire before it engulfs an entire forest. These principles work in harmony to create a robust, resilient design that can handle failures, traffic surges, and unexpected challenges. They are the building blocks of an application that's always ready to serve your users come what may. In the following slides, we'll see how these principles can be applied to real-world scenarios, especially when integrating with YugabyteDB. So let's look at the high-level architecture diagram of YugabyteDB. As you know, YugabyteDB is a distributed SQL database designed for high availability and scalability. We are 100% open source. Its architecture includes distributed storage and distributed query processing, making it suitable for building resilient applications. On top, you will notice we'll have the pluggable query layer. Applications will interact directly with this query layer using client drivers. We have designed it with extensibility in mind. Currently, we support YSQL and YCQL. So YCSQL is a Postgres compatible, and YCQL is based on Cassandra query layer. You can use either one based on your use cases. So bottom layer is DocDB layer. This is the distributed document store. This particular layer is responsible for a strong write consistency, extreme resilience to failures, automatic sharding, and load balancing, etc. Basically, it is shared nothing architecture. This ensures that shards do not get bottlenecked by the compute, storage, and network resources available to a single node. Best thing is that YugabyteDB can be deployed anywhere, on any cloud, on-prem, using Kubernetes, you name it. So YugabyteDB effortlessly integrates into Java applications through its advanced Java Smart Driver. This driver streamlines your interaction with the database, removing complexities and allowing you to channel your efforts into crafting resilient application logic. The smart driver isn't just smart, it's also cluster aware. It's designed to understand the integrate nature of your database cluster, ensuring optimal performance and reliability. Notably, this smart driver is available for all major coding languages, including Python, Go, and more. YugabyteDB's architecture perfectly aligns with Java's strength in handling distributed systems. It's like having a harmonious duo working together seamlessly to achieve outstanding results. So building resilient applications isn't just about principles, it's also about smart strategies. Think of it as having a toolkit of patterns that help you navigate the complexities of distributed systems. So these design patterns are like the seasoned sailor's knots. They keep everything in place, even when the waters get rough. They play a critical role in building applications that can weather the storms of modern computing. Let's explore three key design patterns that are your trusty companions in this journey to resiliency. Number one is circuit breaker pattern. So this pattern is like a circuit breaker in your home. When something goes wrong, it temporarily blocks requests to a failing component, prevents the failure from cascading through your system like a domino effect. It's your off switch when things get out of hand. Number two, retry pattern. Imagine you are sending a letter and it gets returned. What do? You try sending it again. The retry pattern is similar. It automatically retries failed operations, especially those caused by transient failures, until they succeed. It's like a patient sender ensuring their letters reaches the destination. Number 3, bulkhead pattern. Think of this pattern as compartmentalization. Just as the ship's bulkheads prevent water from flooding the entire vessel if there is a breach, the bulkhead pattern isolates components to contain failures. This ensures that a failure in one area doesn't bring down your entire ship, or in your case, the entire application. It's your containment strategy. So these patterns are your allies in keeping your application resilient. They help you manage failures gracefully, minimize downtime, and ensure that your application keeps sailing, no matter the challenges it encounters. In the upcoming slides, we'll see how these design patterns can be applied in principle and how they can complement YugabyteDB's capabilities for resilience. So YugabyteDB isn't just any database. It's a powerhouse when it comes to enhancing application resiliency. Here are some of the remarkable ways it can contribute. Automatic sharding and replication. Imagine your data is like a puzzle and you want it to spread across multiple servers for redundancy and fault tolerance. YugabyteDB does exactly that. It automatically breaks down your data into smaller pieces. We call them tablets. It's more commonly referred as shards, and replicates them across the nodes. It's like having backups for every piece of your puzzle, ensuring data is safe even if the piece goes missing. Number 2, raft consensus algorithm. So this is the backbone of YugabyteDB resiliency. We use the raft consensus algorithm to ensure that data is consistent across all nodes. It's like having a democratic vote to make sure everyone is on the same page, even in the presence of failures. Number 3, CAP theorem. So in the world of distributed system, we often talk about the CAP theorem. YugabyteDB aligns with this theorem by being a CP system with a very high availability. In simpler terms, it prioritizes data consistency and partition tolerance while still providing impressive availability. It's like having your cake and eating it too. Number 4, RPO and RTO. So YugabyteDB does take data recovery very seriously. It boasts an RPO recovery point objective of 0, which means no data loss in case of failure. Additionally, its RTO recovery time objective is lightning fast 3 seconds. In the event of a failure, YugabyteDB detects it and shifts the tablet leaders within 3 seconds, ensuring minimal disruption to your services. It's like having a superhero swoop in to save the day at the speed of light. With YugabyteDB in your tech stack, you're not just building a resilient application. You are building an application that is practically invincible, designed to thrive in the face of adversity. So let's look at this high-level architecture diagram for simple Java app we are going to build using YugabyteDB. I will be using a Spring Boot as a framework for this app. Let's call it workload simulator. And AMP will provide a UI to see your database cluster topology and allow it to initiate workloads right from a single pane of glass, like from the UI itself. We will use Amazon EKS for deploying our app. So this will allow us to provide the resilience and scalability from application side of things. For database cluster, we will use YugabyteDB managed to spin a 3-node cluster spanning 3 different regions in the US. But there's where it gets interesting. We are not just talking about resilience. We are going to demonstrate demonstrate this firsthand, that it has no impact on the users. That's the power of our resilient database. To top it off, like we will horizontally scale out our database cluster This will show you how your application can gracefully handle increased traffic as it gains popularity. It's all about keeping your services responsive even when the demand soars. Let's dive into demo now. So in this demo, we'll do a failover of entire data center and show the impact on your application. So I have spun this cluster in Yugabyte managed called Vivacious here, and I have set the fault tolerance at a region level. So as you can see that I have spread this cluster across 3 different regions: North Virginia, Ohio, Oregon, and it's running right now in AWS. And let's go and take a look at the nodes. So right now you will notice that there are 3 nodes, one in each region, and with minimal or no HR as such. And you will notice that read and write ops per second is currently set as 0. So let's go back to my application, which is deployed on the EKS in US East, and my cluster is spanning across these three regions. This topology is kind of indicating that you have these 3 different regions: East 1, East 2, and West 2. Well, I have already created the tables, but if you are running this app, you can go and create the table yourself directly from UI. Let's seed some data. Like we'll go and put in just 100,000 records or so, just to showcase you what happens when I run any workload. So you will start noticing that as soon as I started that workload, you will start seeing what is my average latency of this simulation which is going on, how many transactions per second I'm doing. And you can see second by second throughput and latency on these on the UI charts on this particular app. So I'm going to go back to my YugabyteDB managed UI, and if you notice, like on the rightmost column, all these 3 nodes are equally taking the traffic. Although my app is sitting only in US East 1, all these nodes sitting across the country, they are working equally hard at the similar rate. We'll quickly fast forward through this insert. So my throughput has gone down to 0. Now I'm going to start some simulation of reading from certain tables. So I will set it up to, let's say, to 96 threads and with 100 million invocations, meaning like I want it to run for a while I'm going to perform certain operations like stopping the region and restarting the region and scaling up the cluster. So you will notice once I start this workload, my new latencies have started showing up, and they are around like 37, 39 milliseconds. Transactions right now I'm doing like 2,500 ops transactions per second. Seeing if I can refresh this UI, and you will notice again, all 3 of my nodes are working equally, taking the workload equally across the board. My application is in US East 1, but I'm connecting to this cluster and it's doing, all these nodes are equally participating in providing the throughput. So I'm going to choose one of this node. And what I want to do is I want to bring down the entire Oregon data center. So this is done by you can do it directly from this UI. I'm just making a call, API call to my YugabyteDB managed cluster, and you will notice that there is one activity which has started, like of stopping that particular cluster node. Very soon you will see that this Oregon will start taking stop taking the traffic, and you will notice that there is a change in latency and throughput. But very important thing to see here is that there is no application is still functional while your entire region is going down. There will be some changes in latency and throughput. In this case, since my application is in US East 1, so my latency is kind of dropped and my throughput kind of increased. So which kind of brings us back to our network latency discussion, which we talked about. So I'm going to fast forward through this, and let it run for a little while, and then I'm going to come back and restart my node so that I want to bring back the region. So earlier I have shown you when I stop that region, stop that node, no impact to application. Same thing I'm going to go do here is that I'm going to restart this node or region back into action, and we'll fast forward through it. It is going to bring back that node. If I was writing some data, it is going to rebalance that the tablets there as well on that new nodes, and to make it consistent across the board. And you will see that again, my throughput and latencies never went down to zero. They kept working. There will be a change when things come back online. There will be, you might notice a little bit hiccups, and where it is kind of rebalancing the stuff. And if you look at the Yugabyte managed UI, you will notice that my Oregon region has come back, and it is equally participating if you look at the rightmost column. And very soon, like it will become very, very smooth. So a little bit of these up and downs you see is mostly the rebalancing and other things which might be going on with the newly for that region which came back up. And this two operations happen, no impact to your applications. That is very, very powerful thing. Now I want to show you if I scale out the cluster with like what happens. So I could have done it directly from this UI because it's like it's an API call, which that Yugabyte managed also makes. But I want to showcase it directly from YBM here. So I'm going to click on Edit Infrastructure. I'm going to choose double my nodes. So from 3-node cluster, I'm going to go to 6-node cluster and confirm and save changes. Within the next few minutes, like it is going to, you will notice the message that it has started updating the cluster. And there will be certain operations which may not be available during that time. And if I click on these view details, you will see different steps it's going to take. Basically, it's going to provision new nodes. It will deploy the database on those new nodes and configure the load balancers and load balance the data. So I'm going to fast forward through this operations, and as you can notice, like if you look at my charts which are going on, at no point my latency and my throughput is changing drastically. Like there will be some little bit jitters, but no changes to your application. So while these new nodes are being added, your application kept running. And wow, now as soon as your application came in, note that your latency fell down, your throughput more than doubled. So that is kind of like a very, very, very powerful thing. Like you need more throughput, you just horizontally scale out your application. And you will notice like now each of these region has 2 nodes. My throughput used to be like 3,000 with earlier setup. And as I came in and I put in new nodes in here, it jumped to around like 8,337 at the latest. And same concept applies while you are doing your OS upgrades or your database upgrades. Nothing changes here. Zero downtime. You can keep running your application database 24/7, 365 days throughout the year. So let's go back to my presentation now. And this is that we saw. Now, we want to talk a little bit about building resilient Java applications. Isn't just about technology you use. It's also about adopting best practices that act as your safety net. Let's explore some of these critical best practices. So number one will be implement comprehensive monitoring and alerting systems. Imagine you are captain of a ship navigating through rough waters. You would want a clear view of what's happening at all times. Similarly, implementing robust monitoring and alerting system is like having a watchful eye over your application. It's like you detect issues before they become problems. ensuring you are always in control. And Yugabyte Managed and Yugabyte Anywhere, it comes with robust tools to monitor all the metrics around your database cluster. Number two, regularly back up the data for swift recovery. So think of data as a treasure chest of your application. You would want to protect it at all costs. Regularly backing up your data is like stashing that treasure in a secure vault. It ensures that even in the event of failure, you can quickly recover and continue your journey. It's your insurance policy for data resilience. Then number three, develop a disaster recovery plan. So sometimes the seas can get incredibly stormy. That's where a disaster recovery plan comes into play. It's like having a well thought out evacuation plan in case of a storm. It helps you navigate the worst case scenarios, ensuring minimal disruption to your services and keeping your ship afloat. As we saw in the demo also, right? Like your complete Oregon region was taken off the grid, and like your application is still kept functioning without a hitch. So these best practices are your guiding principles for maintaining the resilience of your Java application. They ensure you are well prepared for the unexpected and can respond swiftly to challenges. So as we conclude, I want to emphasize the importance of our journey today. So building resilient distributed Java applications is not just an option. It's a necessity in our constantly connected world. Remember the key takeaways we explored together. The principles, the design patterns, and capabilities that empower you to create robust, always-on application. With these tools in your arsenal, you are well equipped to meet the demands of today's digital landscape and deliver exceptional experiences to your users. So that concludes my my presentation. Thank you so much for attending it. Join us on Slack, start us on GitHub. I will take your questions on the chat. Thank you.